All right, everybody. Thank you very much for coming. Thank you very much. We are going to get started right about now. Today, we certainly do have a treat for you. One of the owners of JMI Company, Tom Marini, is here to finally answer the question, which is how the hell do you actually correctly install a pressure transmitter? When it comes to proper installation and maintaining full functionality for the life of the instrument, perhaps the most important thing to have is experience. And with more than 25 years experience, Tom is the perfect man to help us. So we've put a lot into this presentation, and we're hoping that the recording of this can also be used as a reference or a training video, something to send to help educate the new guys or anyone that might benefit from learning the best practices of pressure transmitter installation. So without further ado, I'm going to go ahead and transfer control over to Tom. If you have any questions during the presentation, feel free to use the chat feature and we'll answer them live. At the end, we're going to unmute everybody so that everybody can ask questions in a very informal Q&A style. And that is my introduction for you. Tom, I'm going to transfer control over to you and take it away.
Thank you, Andrew. Thanks for everybody who took time to watch our presentation. Hopefully we'll learn something here today. And actually, I hate to say it, I got 40 years of experience. Now I'm really dating myself. So
40? I made you sound
40.
young.
Yeah, I don't know. But yeah, unfortunately, over those years, I've learned a couple of things and I've seen a few things out in the field. I hope to be able to share those with you today. So the objective of any installation is to maximize instrument accuracy. We want to protect the equipment, simplify maintenance, which is a big one. And I'll bring up some of the examples I've seen out in the field here over the last few years that made that quite difficult, and obviously ensure safety of the personnel who have to interface with the device. Great place to start for any installation is understanding the equipment that you're trying to install. And there's some basic components to every transmitter. It's not overly complex device, but you still have to understand the parts that make up the unit. Key thing here I'm going to point out is the vent and the drain locations on every transmitter. When we put a transmitter in line, especially on gas or steam and liquid applications, we need to make sure that we can get all of the gas entrained or stuck in the line out, completely bled down. And I see quite often transmitters are installed in the field where there is no way to accomplish that after the installation is complete. So every transmitter has a vent and a drain location on it. On the left-hand picture, we see a vent and a vent on the upper portion of the cover flange, drain plug down below. That would be for what we term a horizontal installation. We'll show a little bit more about that later. And if you look at the right-hand picture, there's also a vent, could also be the drain plug and vent located on the end of the cover flange, which would be more suitable to a vertical installation of the transmitter. Not related to the device in the pipe, it's strictly related to the positioning of the transmitter at the end of the sense lines. A couple other things to note. I have seen instrumentation transmitters out in the field that were installed just because it was convenient to mount or have access to the display. In other words, I can see the display, so I'm going to put it in this way. When actually the display, both the amplifier housing and the LCD are rotatable. The housing can be rotated 180 degrees in either direction, and the display 360 degrees in 90-degree increments. So we basically can put the display and housing in any position. So the transmitter should be mounted where the high and low ports properly mount up to the process. All right, here's a better picture of the capsule. As you can see, every transmitter typically will be identified on the capsule where the high and low ports are. We need to make sure they're connected up properly in the field. Oftentimes we see especially after a project where a contractor has put in transmitters and they've tubed up the low to the high and the high to the low. And that can be a problem, especially at startup. Now, nice thing about our Yokogawa transmitters that electronically they can be reversed, at least to get through a startup and not kill time, but eventually that can create some confusion down the road, and you always like to get that corrected. So now we also have a process connection, and spend a little bit of time on that. You've got a 1/4-inch MPT, usually in the cover flange, but rarely do we ever connect process tubing up to that 1/4-inch connection. Usually we either connect it up to a manifold or to the process adapter, which comes with most transmitters, also termed a football often because of its shape. And that mounts to the transmitter cover flange. That way, if you cross-thread a connection or whatnot, you won't trash your transmitter. You will be able to just easily replace the process adapter. There's an O-ring also, typically, that's usually Teflon. That is a source of a leak path, so they should be replaced if the process adapter is removed, which is another thing that's not typically done. A little thing about the process adapters, they are offset. You can't really see from this picture, but the MPT connection on the process adapter is skewed to one side. So for alignment purposes, if I just flip that football over, I can actually adjust the positioning of the connection to match up with my tubing that might already exist. Note that I've also pointed out a little more information on the vent and the drain. Drain plug is strictly just that, a plug. The vent typically will have a bleed screw that allows you to more easily evacuate any gas that's captured in the cover flange. All right, more pictures of vent and drain. Again, this is probably one of the primary things we see. People don't take into consideration the ability to vent out the cover flange and there the sense lines. So you can see in the left-hand picture, we have a vertical with the vent up. That would be more in line with a gas application. And you can also see the horizontal positioning of the transmitter. When we talk about vertical and horizontal installations, this kind of points that out pretty clearly. And at the bottom, the lower picture, you see the drain screw on the vertical installation at the bottom. That would be more for steam or liquid applications. There's a warning note here, which is important. Anytime if maybe I'm not bleeding out a steam line, I'm bleeding out a process where the gases are toxic or the liquid is toxic in the line. You want to make sure that that's rerouted to a safe area so that the technician is not exposed when performing those maintenance work. Manifolds are highly recommended. For every application that we sell, whether it's gauge pressure or DP, Manifold provides an easy way to isolate the unit from process, to also perform zero checks at zeroing the transmitter at pressure, which is preferred, and also provide calibration, a way to calibrate the device without actually removing it from the process. So it greatly simplifies maintenance. Allows you to properly do the maintenance procedures on the transmitter in the quickest fashion. And oftentimes, depending on the manifold and how it's routed, provides safety, allows you to bleed the transmitter and get any toxic gas or liquid away from the unit to keep the technician safe. Versions of manifolds, they come in a lot of different types. You have 2-valve manifolds, 1-valve manifolds for gauge pressure applications. Typically, we like the 2-valve block and bleed, so it allows me to isolate the transmitter from the process, but also bleed off the pressure from the transmitter, and then connect up my calibration device without ever removing the unit from line. Typically, that bleed port is plugged, so in case somebody inadvertently opens up the valve, you're still safe and only have to worry about it when you're doing calibration and that plug is removed. For DP applications, 3-valve manifolds are by far and away the most common that we see. And they come basically with just an equalizing valve and 2 valves for isolation of the process. And also, oftentimes, they can have some additional taps that permit ease of calibration. So you can isolate the transmitter, equalize the sides, connect up cal gas very simply without ever removing the unit from the process. 5-valve manifolds are also pretty common. They come in a number of different configurations. Again, these are just a few of the more common types. 5-valve manifolds in a common version provide 3-valve manifold performance with isolation valves, additional isolation valves for vent and test. And then there's also versions that allow you to actually bleed the transmitter off through a common vent that allow you to reroute toxic gas or liquids to a safe area. Impulse lines, always very important. They transfer the pressure from the process to the device and provide thermal protection in a lot of cases. Typically, the rule of thumb is for gas applications, you want to have the transmitter above the pipe, for liquid and steam below the pipe. But if your gas line is mounted way up in the air, obviously it's a little difficult to put the transmitter higher than that. So there are ways with the lower picture there you show with the drip leg to lower the transmitter below the pipe, allow a drain or a drip leg for any condensate that may be created in the sense line to drip down and be contained with the transmitter tapered back up so that it doesn't collect that condensate. Drip leg can be drained without actually taking the unit offline by isolating the top valve shown there, and then opening up the bottom valve to allow the pot to drain out, and then vice versa when you put it back into service. Again, for steam and liquid application, sense lines must be full liquid. So we need to make sure that we keep them full, balanced, and ideally at the same temperature so we don't get density offset that would cause error in our measurement. We must vent out all the gas, since we're going to keep hitting on that point. We need to make sure that we could vent out all the gas in a gas and liquid application. And if we're mounting this outside, we may want to make sure that those lines don't freeze up. And we can't typically put, for DP applications, put remote seals on a orifice plate because the level of pressure that we're trying to monitor is too small. We'd have to have such a big diaphragm. It is not saying it's impossible, but it's not typical. So usually we were to use wet legs to do that. And in some cases at the south side, we may need to heat trace those lines to keep them from freezing and also keep them at a stable temperature. If the line gets too cold, we can actually have, if we're using an oil per se as an isolation fluid, that oil can get thick, and then our delay time to the transmitter, as it would in a remote seal application, could get very slow. Location of the impulse lines, also very important. For gas applications, obviously we want to drain things out. So we want to be on the top portion of the pipe. For liquid applications, we want to make sure that we keep the legs full. So we want to be on the lower portion of the pipe, but never right at the bottom where sediment, scale, dirt, whatever could build up and get into our sense lines, clogging them up, causing our system to be not functional. And then for steam applications, we usually want to be on the top portion of the pipe, but angled off 45 from center. And reason being is that allows us to better ensure that our sense lines remain full of condensate, especially in steam applications where flashing could be a problem. That is important. It's a quick little chart here. Won't go into a whole lot of detail about it, but the right-hand chart shows how the y-axis actually shows process temperature, and the x-axis, bottom axis, shows how many inches away I need to be from the process via my sense line to ensure that I get thermal isolation from the process. And basically what this shows you is that if I'm in a stainless steel tube, if I'm 10 inches or 12 inches away from the process, I basically have all the thermal isolation I need, and I'm pretty safe. Now, obviously, if the process pipe is very hot, for sake of my maintenance guy, I want to be further away than that typically. But you'll have enough thermal isolation even if you're just a foot away from the process. Okay, mounting locations. We have vertical, horizontal, bottom mount pictures, as you can see. These are good installations. There's also a good illustration of how rotatable the housings are. So we can keep that into consideration. The right-hand bottom mount is also similar to coplanar design, which is a common term. For differential pressure, for this gives a good example of how we would typically install these a DP application, flow application across an orifice plate, very common application. Key things here is usually we always want to have a tap valve, root valve at the orifice or process tap. That allows us to isolate the complete system in case we have a breach or for maintenance purposes. Usually there's also a fill port up top, vent port. It's not shown on this diagram. And then the sense lines are brought down to the transmitter, where we have our transmitter in free valve position so that we can make sure that we vent and drain. There's a lot of different ways to position. We just have to make sure that we can vent them out and drain them out properly. And then we always have those off a T with a drain plug on the main line. That also provides us the ability to blow down those lines without going through the transmitter in the vent. Over time, we get some debris or build up in those lines. For the gas application, we show a unit mounted above, but as I can say, you can also mount that below. Main thing is there we keep all condensate from draining into the transmitter, causing an offset. And for steam, very similar to the liquid application, except oftentimes the angle of the tap off the process a little bit different. But we also want to consider condensate pots, which were something that was very popular 40 years ago. They've kind of got out of favor because after 40 years, a lot of them got full of junk and became problematic. And what people did was typically pulled them out and didn't replace them. Well, the problem with that is on steam applications where temperature and pressure can vary, we can flash off the level of condensate in each of the sense lines. I have multiple calls over the last couple of years of people complaining that they can't get their accuracy of their drum level or their steam applications to work well on their flow because they keep flashing off their lines. What do I do? Well, simple. You put in a condensate pot, it increases the volume. They're usually located up closer to the taps. That additional volume provides enough thermal isolation and enough volume where it won't flash off and significantly change the level in your sense line. You maintain a level, stable condensate level in those pots, and you eliminate any error. So very common if you're having problems with steam flows, accuracy, any problems keeping levels in your sense lines, condensate pot's a good way to go. And there are a number of different variations. Most common is a 3 or 4 inch OD, 6, 9, or 12 inch. Very common. They come in carbon steel, stainless, and usually at minimum we have a inlet port, an outlet port, and a vent or a fill port. But additional blowdown ports or venting ports could also be provided. And again, also termed seal pots. They improve flow measurement accuracy and prevent flashing liquid in the impulse line. That's the key. For gauge pressure transmitter applications, not quite as critical, since if I have an inch offset in my DP line, that's a problem. But if I have an inch in a gauge pressure transmitter, 20, 27, 28 inches of water in a PSI, usually it's not as important, not a big of impact. So on a steam application, maybe I won't put a seal pot in for a gauge unless I really want to maximize my accuracy. But in general, same applications apply as they do for DP, liquid below, gas above, or in a way where I can ensure I don't get condensate in the transmitter, and steam line like water typically. Also have MPT style mounts, very common for gauge pressure. And there's a number of different adapters that are readily available, including the right-hand picture shows a pigtail circular little thing common for steam applications. And again, we always use a manifold and typically also would have a root valve at the tap. Very common sources of error: poor pressure transfer, sense line leaks, trapped gas in the liquid line, liquid in a gas line, dirt in the lines. There's also a note here about purge lines. That picture shows a purged application, not very common, so we won't get into that. But making sure that we just follow some of the common practices we talked about. You should avoid these problems. Things to consider: sense lines should be kept short as possible. Avoid high points in liquid lines that would cause a trap where condensate or liquid could form, or actually a gas could form. And in gas lines, low points that would cause a trap. We want to make sure that we try to keep the impulse lines the same temperature so that their density remains the same. We don't want to use 1/4-inch sense lines. Typically 3/8 or half are very common. That way they transfer the process better, and they also allow for a much better transfer of the pressure. They don't clog up as easily. Keep liquid out of gas lines, gas out of liquid lines, prevent sediment deposits from building up. Also, transmitters typically have a 250 or 280 degree max. So you want to make sure that the hot process when you're going through maintenance doesn't get bled through the transmitter housing. That would be a problem. Startup. This is important. Main thing here is we need to make sure if you start up the transmitter incorrectly with your 3-valve manifold, you can overpressure a transmitter and cause the calibration to shift. Typical procedure would be to open up the equalizing valve first, then open up the block valve for the high side. Then that would allow high pressure to be on both sides of the transmitter, shut the equalizing valve, and then slowly open up the low pressure side isolation valve. By doing that, you will make sure that you don't blow out the fill fluid, the condensate in your low pressure side by improper operation or sequencing of the valves. Shutdown procedure, again, pretty straightforward, kind of the reverse, and I think that's pretty clear. This is just a quick note on an Accelabar showing that there are a lot of different manufacturers that show different types of installations. They usually have a nice picture. They'll show you how to do it. Sometimes you can close couple of transmitter, eliminate the sense lines, but when you do remote the transmitter, they're all going to have the same things that I've discussed. Isolation valve at the tap, usually a fill T, a drain or a blowdown valve at the main line, and a 3-valve manifold off of a T with the transmitter in a position where it can be bled down properly. Summary: select the right transmitter for the range. Your salesman can help you do that. Follow recommended installation guidelines. Select the mounting locations that's accessible and easy. I see too many times they mount the transmitter with the wiring cover, back wiring cover up against a wall where you can't possibly get to it. If you make that mistake, then you're less likely to get good maintenance from your technicians or your sales guy for that matter. Keep sense lines run short and straight as possible. Keep wet legs full and bounced. Properly zero your transmitter before operation. Follow proper operating procedures so you don't overpressure the unit. Isolate the transmitter before blowing down sense lines, and minimize ambient temperature swings if possible. In some cases, that means putting your transmitter inside of a heated enclosure if it's outside to maximize its accuracy. Well, that's the quick 22-minute, went a little over, but overview. Doesn't cover everything, but it gives you a good basic knowledge of things to avoid. And if you have any questions, I'd be glad to field them now. All right.
You did go a little over, but I got a lot out of that one. So thank you.
Not a problem.
I am going
a lot to cover in 15 minutes. So
yeah, no, I agree. Putting 40 years of experience into 15.
Yes, you undercut me.
So right now, everybody, I'm granting mic access to you, and then I'm going to check the chat in just a moment. One of the nice things about having Tom as a presenter is you can ask any question you want, and we'll probably have the answer for you. So feel free to get started here. Somebody did have the question, Tom, how is blowdown done, and how often is it suggested? Let me know if you want me to navigate to a slide.
Application specific. Some applications where you might have the transmitter on a very dirty process, blowdown might have to be done weekly. Um, Certainly, usually I would say anytime if you're on a steam line and you're doing a semi-annual calibration, maybe you want to at least once a year blow those lines down by isolating the transmitter. Again, being safe to make sure that you don't blow steam out onto somebody. But yeah, it's really application dependent. And to do that, to blow it down, it's simply a matter of isolating the transmitter from the process, typically with your 3-valve manifold. And then the drain valve at the bottom of the line should be opened up to process pressure, again, if that's safe. And if it's not, then those lines need to be routed to an area where it would be, and allowing process pressure to flow through the sample lines. Very common with steam applications where you get sediment and whatnot build up, and allow those to blow out any debris that's been in the lines. Shut the drain valves back. You may have to refill those lines at that point, and to ensure you got a balanced condensate leg, and away you go. So in some applications, like an air application, you may never have to do it. So hope that answers the question.
I think that's a good answer. Everybody also, if there are any slides that you wanted to take a look at or any clarification you needed, you now all can move about the slides. So you can move back and forth just like I was doing. I just brought it up to the 3-valve slide. And so just checking to see if anybody else has any questions. Thank you guys very much for your time. We do usually do a little bit more Q&A, but I know we're coming up on lunch, and so I want to be respectful of your time. Feel free to stick around, ask as many questions as you like, but if you have to get going, I know it's right around noon. So thank you guys. You're all going to receive a recorded version of this as well, so you can reference it, you can send it to other people, and you can snip it at any given point to share the information with everybody. So it would look like some people are scrolling through the slides, taking a look at a few things. So we'll give them a few more minutes, Tom, and then we'll.
Okay. I got nowhere to go. I know, right? 40 years, I don't move fast these days.
Oh boy, guys! I also have a real live pressure transmitter. My God, a real one right here. So if you have any questions specific, this was the electronics. This was the plate that Tom was talking about. Where here's the face, here's the display. If you install this thing where there's a wall right here, right behind it, let's do this. If you install it with a wall directly behind it, so the wall is like that, it makes it very hard to access anything back here.
One thing I also didn't get into was the wiring. And 2-wire, obviously you have a plus and a minus, but there's usually a third terminal. It's called a test. It's almost common on every transmitter. That is actually a way to do a quick 4 to 20 loop check or output check. It's a mimic of the actual current on the loop. It just won't support any load. So you couldn't put a resistor on it or hook it up to a device. But it does allow you to take a current meter up and run it across the common and test port, and you can measure the 4 to 20 output, which should be identical to the output going to your control system. So since for current measurement, you need to break the line, that gives you a way to measure the current in your loop without actually breaking the line and taking the meter offline.
All right. We have one more question that's come through, and the question is, can you set up the transmitters without a Hart handheld? And I'm going to take you to a certain slide in the beginning to start answering that question. Short answer is yes. Tom, go ahead, and if you want to elaborate.
Yeah, it is possible. You can't really see it on the display, but there is a little push button on the display that allows you to do a span setting, a 0 and span setting on the transmitter.
Can you see that, Tom?
Yes.
Okay, so there's that little button down there. Go ahead.
So typically it requires that you have a pressure source so that you could pressurize the unit up. Let's say you want to span the unit to 0 to 100 inches. You would apply that pressure, hit the buttons in the sequence that you require, and then and then go through and you're done. So you wouldn't need a hard handheld necessarily to do it. Obviously, that may be a little more cumbersome than actually having a communicator. The other thing that you could do with our transmitter and many others is there is a zero adjustment screw. And that allows you to, when you mount a transmitter, there's a little bit of fill fluid in every transmitter. So once they're mounted, you always have to go back in and zero those units. Typically, you'd like to do that under process pressure as well. 3-valve manifolds allow you to do that. So you allow process pressure to stabilize, sometimes isolate the unit from the process in case there's some variations. Then you can go and with the zero screw, actually turn that screw to zero out the transmitter for DP application. And you're done. For a level application, that also allows you to adjust the level of a transmitter. If you know it's 50% full, or if you got a sight gauge, you set the transmitter up to say 0 to 100 inches or whatever your level is in the tank. You know it's 50% full. You can actually take that screw and adjust the whole range to offset it, suppress it, or elevate it so that it reads 50% at the current level to match your sight gauge. So it's kind of a handy thing. There are things you could do without a handheld that are available on the transmitter, but handhelds are highly recommended. They make life a lot easier and give you access to all kinds of parameters.
So what Tom is alluding to is here is the zero adjustment screw, and he went through a couple of the parameters. When this is powered up, obviously, you press that button, and you get to this local parameter setting is what it's called. And you can adjust level. You can adjust, I think, 9 different parameters, basically by toggling through here and then using a screwdriver right here on the zero adjustment screw. So that is one way to do it without with no heart handheld. Another way to do it is through a software that many companies have. Our Yokogawa version is called FieldMate, which you would essentially hook up this transmitter to your laptop, and you can adjust all of the parameters there as well. So if your field guys are walking around with laptops and they can hook them up, we can supply, hook the transmitter up to a free software. They can adjust and view all the parameters on their laptop without having to carry around a heart handheld. So it still can be done with a heart handheld, but there are 2 options that does not need one. One is through the display and the zero screw, and the other is through a software that is free.
You need a heart modem.
Do need a heart modem, correct. So, okay. Well, guys, we are at our time limit here. Thank you very much for joining us. And feel free to email us. You're going to get emails from us with the recorded version. If you have any follow-up questions, any applications you want to discuss, we'll be sure to give Tom the let Tom know, hey, these guys went on the webinar and now they want your help, right? Yeah.
We're always happy to help.
All right.
Guys. Really appreciate the time.
Thanks, guys. We'll see you next week.